Alright guys, here's a walkthrough tutorial on how to complete the broken pelvis worksheet that we had for review. Looking at question number 1, it says what year was this map made, when was it originally made, and when was it revised. All that information is always given in the lower right hand corner of any topographic map. So the year that it was made was 1971, and then it was revised in both 1984 and 1990. Then the next question it asks is, what part of Colorado is broken pelvis located in? That's always given to you on any topographic map right here. It shows the state of the area that you're talking about, and the dot that's given to you right here shows where broken pelvis is. So this would be kind of like the western central part of the state. Number 3, it says if you wanted to look at the area directly south of broken pelvis, what map would you use? And so the borders for all the other surrounding maps are always given to you in these parentheses right here. So Lulu City is directly to the south. We have Central City that's directly to the east, Apex Point's to the north, and Cripple Creek is to the west. So to answer the question, if you wanted to look at the map directly south, you would need to go ahead and look at Lulu City. Okay, now looking at the second page, we start to get into some latitude and longitude directions. It says, including direction, what is the southernmost latitude? Including direction, what is the easternmost longitude? Because this is North America, I already know the latitude's going to be north. And because this is North America, I already know that the longitude is already going to be west because it's to the left of the prime meridian. Now all I need to do is get the numbers. So let's go ahead and take a look at the southernmost latitude. The southernmost latitude is given to us right here. So it's 36, 37, 30. So I'm going to go ahead and fill that in. 36 degrees, 37 minutes, 30 seconds. And I'm going to go ahead and look for the easternmost longitude on the map. The easternmost longitude on the map is given to us right here. It's the 105 even. I'm going to fill that in. 105 degrees, 0 minutes west. Next it says, what are the latitude and longitude in the northwest corner of the map? So I'm going to go ahead and go to the map. Take a look here. In order to answer that question, I need to take a look at the surrounding areas. If you'll notice in the northwest corner of the map, I don't have the latitude and longitude. It's left blank. But there is some information I know that can help me out. I know that this line here is a line of latitude, and that if I'm walking anywhere along this line, my latitude does not change. So, as long as I look at this point of latitude right here, I know it's the same point of latitude that's right there. So that's in fact the latitude for the northwest part of the map. That would be 36:45 even. So I'm going to go ahead and put that 36 degrees, 45 minutes, 0 seconds, and I know it's north because it's above the equator. And now I'm going to go ahead and take a look at the longitude. If we take a look in the top part of the map, there is no longitude that's given. But again, I know that everywhere along this line of longitude, my longitude is the same. It does not change. And if we take a look at the southwest part of the map, the longitude's given. So the longitude here is going to be the same as the longitude up here because I have not changed longitude. I haven't gone east or west. So the longitude for the south, for the northwest corner of the map is going to be 105,730. 105 degrees, 7 minutes, 30 seconds. And that's west because I'm to the left of the prime meridian. I'm in North America. So number 7 says use the bar scale to determine the straight line distance from point S to point K. All right, using the bar scale is pretty easy. We wanted to find the points between K and S over here. So what we do is we take a blank piece of paper, line it up along K and S, put a line at K and a line at S. Take that blank piece of paper, move it to the bottom of the bar scale. The only trick here is to be careful that you start at 0. I'm going to mark my largest distance, which is 5 miles. And then notice that I have a little bit of distance left over. And instead of just guessing that it's a little bit under a mile, I'm going to move it to this broken up mile. And notice that I go to 5.7 miles. 5.7 miles. That's 7/10 of a mile right here. So it becomes 5.7 miles. And that's our answer. Number 8 says, what's the surface elevation of Kelly Lake? Real simple. That's given to us right here, 630 feet. 630 feet. Next on number 9. Number 9 says a benchmark is a place where the map maker actually stood to determine the elevation, and it's always marked on the ground. So what's the elevation of the benchmark in the northeast corner of the map? So we just scroll up. Here's our benchmark right here where it says 712, BM 712. So our elevation at the benchmark is 712. And that's 712 feet above sea level. Next it says, what's the contour interval for the map? So I'm going to scroll up here and take a look. Alright, so right here in the map, I have an elevation of 600 feet above sea level. Here's 700 feet above sea level. Subtract them, you get 100. 100 divided by 5 is going to give you 20. Why divided by 5? Because there's always 1, 2, 3, 4, 5 lines from one index to the next. So the difference between them is 100 divided by 5 lines. That's going to be 20 feet per line. Going to throw that answer in there. It's just 20 feet. What are the units used to measure all elevation points? That's feet. What is the starting point for all elevation points? That's sea level. Next, what is a contour line? It's a line that connects areas of equal elevation. Next, what is an index contour? It's a bolded and labeled contour line. Next it says fill in the elevation points. If there is a range, include the range as well for A, B, C, D, K, and S. So let's go ahead and do that. Little suggestion, let's go ahead and start out by labeling the contour lines on the whole map. So here's 600 right here. That would make this 620, 640, 640, 660, 680, 700. Up here is 720. Here's 740. A couple more to label. Here we have our 700 here. Here's another 720. And here's a 740. All right, so looking at these, from one to another, point A is right over here in the bottom right-hand corner. The max elevation for that hill is 759 feet above sea level. Why? Because at 760, I would have to draw another contour line. So we have to assume the max possible elevation is as high as you can go without having to draw another contour line. Point B is a range. It's over here in the center left. It's a range of 621. It's a range of 621 to 639. It can't be 620 or else it would be right on this line, and it can't be 640 or else it would be right on this line, so it has to be that range between them. Point C is right on a line going back to the right-hand side. It's 680. We've already labeled that line, and if we follow it along right here, it'll bring us to the elevation that we've already labeled, or we could also go ahead and take a look and notice that it's one contour line less than this 700 right here. And since our contour interval is 20, it's going to be 680. Next, if we take a look at point D, it's another range, and that's going to be 661 to 679. Point K is right on a line. It's 640. and point S is right on line, it's 740. That should take care of all the points. Here are the answers right here, including the ranges. All right, next it says, notice that point A is the center of a hilltop. What's the maximum possible elevation? We've already answered it. The maximum possible elevation is 759 feet. Again, we have to assume it's 1 foot less than the maximum elevation that you would have if you were to draw another line. What direction does the river flow between S and K? We know that this is a higher elevation than this. K has a lower elevation, S has a higher elevation, and water flows downhill, so it's flowing to the southwest. But we also know that contour lines make little V's that point uphill. So if uphill is this way, water will flow downhill, which is to the southwest. So that answer is southwest. And then it says, is there a greater change in elevation in the northwest or the southwest part of the map? So comparing the northwest to the southwest part of the map, here's our northwest and here's our southwest. Notice that in the southwest section, the lines are really close together. So we said that there's a steeper gradient there, or a larger change in elevation. So the southwest corner certainly has a greater change in elevation. That does it for this walkthrough tutorial. If you have any questions, please see me in class or shoot me an email.